Okay, reviewing absolute convergence and conditional convergence by looking at number 23 in the homework in 9.5. So we're asked, does the following series converge absolutely, conditionally, or diverge? Here's the series. First step, I should see clearly. Test for absolute convergence. I put absolute values around this, and now I'm evaluating this series, n plus 1 over n squared. I say, I'm going to do the limit comparison test to 1 over n, which diverges. I take the limit of, as n goes to infinity of n plus 1 over n squared divided by 1 over n, and I get 1. Therefore, I conclude it diverges. So now it failed absolute convergence. I test the original series. Negative 1 to the n plus 1 times n plus 1 divided by n squared. This is an alternating series. The only requirement is the a sub n's limit as n goes to infinity of n plus 1 over n squared. Dividing top and bottom by the highest power, I get this, which is 0. So it converges. So the conclusion is this series converges conditionally. Now, I made up another problem asking the same thing. Does this series converge absolutely, conditionally, or diverge? I test for absolute convergence, absolute values. Now, so I'm testing n squared plus 3 over 3 to the n, 3n to the 4th plus n. I do the limit comparison test to 1 over n squared, which converges. Here it is, limit as n goes to infinity of this divided by 1 over n squared will give me n to the 4th plus 3n squared over 3n to the 4th plus n, which equals 1/3. Therefore, making them all positive, it converges. Therefore, it converges absolutely. I am done. So, back again. I want to see, when you're doing a problem like this, these steps. You don't sit here and say, oh, this converges. You test for absolute convergence. You get a diverge. Then you test for the original series. It's an alternating series. I need to see this step. It converges here, diverges here, therefore conditional convergence.